So before we get started with special right triangles, I want to point out a couple of things that we're going to need. We didn't get a chance to do this in class, so I want to point out a couple of things that you're going to need going into our next lesson. One, multiplying radicals. Whenever you multiply radicals, anything that's underneath the square root is going to be multiplied together, and anything that is outside the square root is going to be multiplied together. So for instance, if we look at these 6, 7, and 8 right here, when you multiply the square root of 3 times the square root of 7, it is equivalent to the square root of 3 times 7. You can combine them under one square root, and then 3 times 7 is the square root of 21. And you can always leave out that middle step, but I just want you to have it so that you understand how things are working. And number 7, notice that you have numbers that are outside the radicand, and you have numbers that are inside the radicand. So what's going to happen is you're going to group them together so that your numbers outside get multiplied together and your numbers that are inside get multiplied together. And we're going to condense them into one single square root. Well, 5 times 6 is 30. And then we have the square root, and then 3 times 2 is 6. Now, probably the most important one that we're going to use today is this one, the square root of 3 times the square root of 3. Well, if we condense this into one square root, the square root of 3 times the square root of 3, well, then that simplifies. 3 times 3 is 9. Well, you always want to double check, but the square root of 9 is a number that we actually know because 9 is a perfect square, so that's 3. Now, here's kind of a little helpful hint. The square root of 3 times the square root of 3 is 3. So the square root of 5 times the square root of 5 is 5. The square root of 17 times the square root of 17 is 17. And so if you recognize that pattern, then you don't have to go through all the work of putting them underneath one radical and then multiplying them together and then taking the square root of that. Okay, so that is going to be helpful for what we're doing today. And then let's look at a couple of these. Let me show you how it works, and then we'll kind of go into the trick. So if I have 8 divided by the square root of 2, in math, we don't like to leave square roots in the denominators, and so we want to get rid of it. And so the easiest way to get rid of it is to do what I just said. Remember when we did the square root of 3 times the square root of 3, we got 3? So that got rid of the square root. The problem is you can't just multiply by the square root of 2 because you want to, but we can multiply by 1. So we just want to be creative about what 1 we multiply by. Well, we know that 3 over 3 is 1 and 5 over 5 is 1. So the square root of 2 divided by the square root of 2 is also 1. So I'm just multiplying by the square root of 2. So now let's do what we just talked about. So we have 8 times the square root of 2. 8 is on the outside. 2 is on the inside. So they can't be multiplied together. So that's 8 root 2 on top. Okay, so this right here gave me this right here. And then root 2 times root 2, if you recognize the pattern, remember we should be able to skip all the way to the end. Root 2 times root 2 is 2. Now, notice that the 2 isn't underneath the square root, and the 8 is not underneath the square root. But this 2 is, right? There is a 2 underneath the square root, but we can't touch it because it's underneath the square root. It's in the house, you can't get to it. But we can reduce, this 2 goes into 2 one time and 2 goes into 8 4 times, and so that reduces to 4 root 2. Now notice 8 divided by 2 is 4, and then we have a root 2 on the end of it. Okay, so let's look at another one. Again, we want to get rid of that root 3, so we multiply by root 3 over root 3. Whatever square root is on the bottom, that's what you want to get rid of. So you multiply across the top, 9 times the square root of 3, and we just write that because you can't multiply them. One's inside the house, one's outside the house. And then the square root of 3 times the square root of 3 is 3. Remember, the square root of 3 times the square root of 3 equals the square root of 9, and the square root of 9 is 3. And again, now look at your numbers that you have that are coefficients that are outside. You have this 9 and this 3. They reduce to 3, which is 3 root 3. So it's kind of interesting that 8 over 2 was 4. 8 over root 2 was 4 with a root 2, right? 8 divided by 2 is 4, and then it had a root 2 on the end. 9 divided by 3 is 3, and then it had a root 3 on the end. So what do you think then 15 divided by the square root of 3 is? Well, it is 5 root 3. 15 divided by 3 is 5, and then you have that root 3 on the end. Now, when you have a problem like number 14, look at what you've got. Already you start out with a root 3 on top and a root 3 on bottom. You know what happens? Those two cancel out. We're going to simplify them before we ever even get started. Always look at your fractions and see if you can simplify them before you do anything else. The same thing with number 15, right? I don't have a square root in the bottom, so I don't need to rationalize it, but I do notice that there's a 12 on top and this 2 in the denominator. Those cancel out and leave you with 6 root 2. So you always want to be able to simplify. You always want to simplify when you can. Now, having said that, we're going to talk about 30, 60, 90 triangles and 45, 45, 90 triangles. They're called special right triangles. They're special right triangles for a reason. We have been talking about proportions, and proportions was when I had two triangles that had the same scale factor. Well, if you remember, we talked about, because of AA, that if you have two angles of one triangle congruent to two angles of another triangle, then those two triangles are similar. Well, what happens is if you have a triangle, two triangles that are 30, 60, 90 triangles, or 45, 45, 90 triangles, then they're going to be similar to each other. The cool thing about it is that they are always going to have the same ratio. It doesn't matter how big or how small, they always have the same ratio. So they have a built-in pair, right? And every other one we had to have our big triangle and our little triangle, and then we could set up our proportions however they were. But you always had to have your two triangles. Well, when you see a triangle that's the 30, 60, 90 or a 45, 45, 90, you don't actually have to see that second triangle, you automatically have it. So let's look and see what those ratios are. We're going to use Pythagorean theorem to find these triangles. So you notice, to find these ratios. So notice that these two sides are congruent to each other, so x has to also be 3. Because that's a 45-degree angle and those two sides are congruent, this is a 45-degree angle. Those two add to 90, which means this is 90. Now that gives me the right to do Pythagorean theorem. So a squared plus b squared is equal to c squared. Now, you're not going to have to know how to do this, okay? I just want you to see where these numbers come from. Well, 9 plus 9 is 18, and when you take the square root of both sides of that and you simplify it, you end up with 3 square root of 2. So we had sides that were 3 and 3, and then this side, oh, I wrote root 3, but I should have written root 2. I'm sorry. That's root 2. So we had 3 and 3 and 3 root 2. Those are the numbers that we had. Okay? Now, here's what's cool is if I had sides, let me come over here, write them in a different color. If I had this side was 5 and this side was 5, you know how long the hypotenuse would be? 5 root 2. It will happen 7, 7, 7 root 2. They always have the same pattern, and I can use Pythagorean theorem to prove it. Now, if I were to go in and I were to reduce these by what they have in common, if I divided by 3, because they all have a 3 in common, what I end up with is 1, 1, and root 2. And those are what we call our magic numbers for 45, 45, 90 triangles. So our two sides that are across from our 45-degree angles, they get 1s. So there's a 1 and a 1. And then our root 2 goes on the hypotenuse, okay? So that's your second triangle. Whenever you see a 45, 45, 90 triangle, that's going to be your second triangle that you use. And it is on your formula chart, so you'll be able to remember it. Now, let's look at a 30, 60, 90 triangle. So we have this triangle. I know that these are 60 because all three sides are congruent. And that top one became the angle bisector. So the altitude became the angle bisector. And so now what I have, if you notice, I've got this little 30, 60, 90 triangle right here. Okay. And so I know that the hypotenuse is 10. I know that because this was 10 and this was 10 and that altitude cut it in half. So now that means that x is 5. Now, if I do Pythagorean theorem, I would have y squared plus 5 squared is equal to 10 squared. Again, you don't need to be writing. You can just listen. Okay, so then I have y squared plus 25 is equal to 100. Subtract 25 from both sides, you get y squared is equal to 75. And when you take the square root of both sides and you simplify it, you get y is equal to 5 root 3. So y is 5 root 3. Now, notice that the hypotenuse is twice as long as the side that's across from the 30-degree angle. And then the long leg, or the side that's across from the 60-degree angle, is the square root of 3 times the short leg. Everything is in relationship to the short leg. Now, again, if I go back in, divide by what they all have in common, they all have a 5 in common. I can reduce this triangle. Then I have 1. And then my hypotenuse, 10 over 5 is 2. And then 5 root 3 over 5 is root 3. That gives us our magic numbers for 30, 60, 90. Now, the hypotenuse is always across from the 90-degree angle, and that's always going to be your 2. Okay, so your 2 always goes with your hypotenuse. Your short leg, remember the short side goes across from the small angle. The small angle is the 30-degree angle. And so it is always opposite of your small one. That's where your 1 goes. And then your longer leg, which is the side that's across, it's your medium, it's your longer leg, it's your medium side, but there's 2 legs and 1 hypotenuse. And you have your short leg across from the 30, you have your longer leg across from the 60, okay? And that's going to be your square root of 3. So that's where your root 3 goes. Now, we're going to keep using our proportions just like we've been doing, but you want to keep these triangles handy always. Okay, so you always want to keep these triangles wherever you can see them. And whenever you see a 45 or a 30 or 60 in your triangle, know that you're going to do this. So keep these triangles visible, and here's what we want to do. Now, I can look at this example A, and I can see 4 and 4. Now, when I have 4 and 4, don't forget, that automatically tells you that this is a 45-degree triangle. Okay, so here's what I want you to do. We're going to put, just like we've been doing, where we put our 2 triangles together and we pull all of our numbers onto one triangle, we're going to do 4 over 1, and x over root 2. So you're going to take each of these numbers here off their corresponding side, and you're going to put them underneath the triangle that's the problem. Now, when you set this up, the reason I want you to do this is because now look what you've got. I want to find x. So we're going to use this fraction right here, x divided by the square root of 2. So x over the square root of 2 is equal to, and it doesn't matter which one you use because they're both the same, so 4 over 1. So equals to 4 over 1. Now, if you go back to what we've been doing, now you can cross multiply. But notice there's no need to do that x times 1. So we do x times 1, which is 1x, and then we do 4 times the square root of 2, and we get 4 root 2. You can't multiply the 4 times the 2 because the 4 is outside the square root and the 2 is inside the square root. Okay, so again, I can tell in part B that this is a 45, 45, 90 triangle because the 2 legs are equal. So I'm going to set up my proportions, 1, 1, and root 2. I want to solve for x, so I use my x fraction, x over 1. Just write it down, and then we'll worry about cleaning it up. Set it up, then clean it up. And then we're going to use the 1 fraction that has all the numbers in it. So we have 20 root 2 over root 2. Now that looks scary, but remember I said whenever you can, you always want to reduce your fractions. And so when you go through, we look at that fraction on the right, 20 root 2 over root 2. We have a root 2 in the numerator and a root 2 in the denominator, and they're going to cancel out, so we can just clean that up. And so then we just have x over 1 equals 20. And so when you cross multiply that, there's nothing on the bottom of one side. It's just 20 times 1, and you get that x is 20. If you do the same thing, now if you notice, right, it's 1 and 1. If you get good at these patterns, you're going to notice that your 2 legs are always the same. It'll save you a step so that you don't have to do this again, right? Those cancel out. You multiply 20 times 1, you get y is 20. Okay? So every time we see these two legs are equal, this has to be a 45, 45, 90 triangle. Set it up. What are my pairs that go with it? It's 1 and root 2. So we want to solve for x. X over 1. X over 1 is equal to 20 over root 2. Now, you can multiply, y'all, and here's where this is a little easier than what we've been doing because there's no need to actually multiply. So just let your x sit there, let that x sit, and then do the rest of the math. And so we would do 1 times 20, right here, that's 20, and then we have 20 divided by the square root of 2. Well, remember that shortcut, 20 divided by 2 is 10, and then there's a square root of 2, so we put that square root of 2 on there. Sometimes they will leave it 20 over root 2, but you don't have to. And then we have y, and again, if you don't recognize that pattern yet, 20 over root 2, leave the y where it sits. We don't have to do anything with it. We don't need to multiply. We can just anything by that y because we want to leave it by itself anyway. So 20 times 1 is 20, and then we have 20 divided by the square root of 2 is 10 root 2. Now, one thing you always want to notice, because of the 1 and 1, those two sides are always going to be the same. Whatever they are always going to be the same. That's the nature of that isosceles triangle. Now, let's look at some examples here with D and E. Now, D and E are 30, 60, 90 triangles. So we have our 30. So here's what you want to do. First thing you always want to do is you want to go find your reference triangle. So my reference triangle is right here. Notice that the 1 is across from the 30. So I'm going to put the 1 across from the 30. Here's my 30, and here's across from it. So I'm going to put the 1 underneath the 7. Your root 3 goes across from the 60, so I'm going to put my root 3 underneath my x, and then your 2 goes on the hypotenuse. So your 2 goes on the hypotenuse. Sometimes I like to put the 1 and then the 2, and then the root 3 goes on the leftover side, just because it makes more sense to me. 1 and then 2, and then I like to put the root 3 in. So now I want to solve for x. Well, here is my fraction that has to do with x. So I have x over the square root of 3 is equal to, and we want to use the other fraction that has all the numbers, 7 over 1. Again, we're just going to leave our x where it is. So let's multiply both sides, or cross multiply, right? We're going to multiply both sides by root 3 and root 3. And 7 times root 3 over 1 is just 7 root 3. Okay, and then y over 2. So we're going to do our y. So we have y over 2 is equal to 7 over 1. Leave your y where it sits, multiply by that root, or by that 2 right there, that 2 times 7, and that's over 1, so we can just ignore that 1, and so we get y as 14. Now, notice, look, if you go back and you put these numbers in, this side was 7, this side is actually 14, and this side is 7 root 3. That's the pattern we had? We had our 7, we had our root 3, and we had our 2. Right, or 2 times 14. So we said that the short leg times 2 is always the hypotenuse, and the short leg times root 3 is always the long leg. That's always going to be the pattern, and you may or may not be able to start using that. Okay, so question E, we've got our short side, so we've got our 30 degrees, so we put our 1 underneath our x. I like to go ahead and deal with my hypotenuse, so I'm going to put my hypotenuse on 2 underneath my hypotenuse, and then I'm going to put root 3 underneath here. Now, one nice thing you could do to kind of help make it a little bit prettier is clean that up and just let it be 12. Now, the side length is still 12 root 3. I'm just going to do the math. So we just now set up what we've got. So we have x over 1 is equal to 12 because I already canceled everything out. Well, x over 1 is equal to 12, so x has to be 12. And then y over 2 is equal to 12 because we already cleaned it up. That makes this fraction part. I could have done that on B also. I could have cleaned it up here. I could have also canceled out that root 2 from the beginning. And then y would be, you need to get rid of that divided by 2, so you multiply by 2, and you get that y is 24. So you need to, I would recommend that you pause the video and then you try to solve the rest of these problems on your own. I'm going to work through them kind of quickly, but you can go through and you can just check your answers. So the big thing is just remembering where to get your reference numbers. As soon as you see a 45 or a problem that could have a 35 or 45, then know that this is how you're going to set it up. So all 45s have 1 root 2. So it's over 1, and over root 2. And then solve your problem. So you have x over 1 is equal to 42 over 1. And if you want, you can just simplify when you get here, right? So we leave our x alone. 42 over 1 is 42, and then times 1. So we cross multiply and then divide by 1. Well, they all cancel out, and so x is 42, which makes sense, right? This side would be 42, 42. And if you know your pattern, then you know that y has to be 42 root 2. But if you don't, that's okay. Y over root 2 is equal to 42 over 1. We're going to leave our y right here. We're going to get rid of that root 2 by multiplying by the square root of 2. Or cross multiplying, right? 42 times root 2 is 42 root 2. Okay, so we do our next one. Over 1 over root 2. I notice, oh wait, there's a root 2 in the numerator and the denominator. I'm going to cancel those out. And then I'm just going to deal with this. X over 1 is equal to 15. Well, so that means x is 15. That means y is also 15, right? Y over 1 is equal to 15. If you don't see that, if you don't recognize that you can cancel that yet, that's okay. X over 1 is equal to 15 root 2 over root 2. Cancel them right there. You just always want to cancel whenever you can because it makes life a little bit easier. Okay, again, this is a 45 because this is isosceles, so over 1 over root 2. So I have x over 1 is equal to 24 over root 2. And again, that's that shortcut. You could leave it like that, or you can do 24 divided by 2 is 12, and then a root 2, because you actually divided by the square root of 2. And then y has to be the same, 1 and 1. They're going to match up. Y over 1 is equal to 24 over root 2. And again, that's 12 root 2. The hard part is remembering when do you use the root 2, when do you use the root 3. But you have it on your formula chart, so you don't even have to memorize that. Now this triangle looks a little bit funny because it's turned over, but it's still the same, right? Your hypotenuse is still here across from your 90-degree angle, so you want to make sure that you can find that. Then you put your 1 and your 1. So let's set it up. Don't worry about what it looks like. Don't try to solve it all at once. Just look at it. So x over root 2 is equal to 2 root 3 over 1. Now, when you cross multiply, remember this goes back to where we were multiplying them. You have that 2 that's outside the square root of 3. You have the 2 that's underneath the square root and the 3 that's underneath the square root. Remember, when they're in the same place, you can multiply them. So you have the 2 on the outside. This 2 right here, you have it on the outside. That's 2. And then you have the root 2 times the root 3. That's root 6. And then you ignore the 1. You don't divide by 1. It doesn't impact anything. See, that way you don't have to worry about it. When things don't look the way that they're supposed to, right? Normally our problems don't have root 3s in them, but that's okay. We can handle it because we're just going to go with the math. Then we want y. Y over 1 is equal to 2 root 3 over 1. Well, if those two are the same fraction except for the y, then y has to be 2 root 3. Or 1 times 2 root 3 is 2 root 3. Now this is a 30, 60, 90, and so you have to pay attention to your angles. Your 1 goes across from your 30, your 2 goes on the hypotenuse, your root 3 goes on your leftover side. Now you've got everything set up to do your proportions. So now we can come over here and we can do x over root 3 is equal to 20 over 2. Again, one thing you can do, figure this out how you want to handle it, but 20 divided by 2 is 10, and then 10 times root 3 is 10 root 3. Y'all, 10 root 3 means 10 times root 3. Just like 10x means 10 times x. We just don't say times, but it is times. You could type it in on your calculator that way. And then y, we have y over 1 is equal to 20 over 2. Well, you could cross multiply. If you don't see it, you can cross multiply. 1 times 20 is 20, and then divide by 2. But really, there's no need. Just let your y sit there. 1 times 20 is 20, divided by 2 is 10. So y was 10. This side was 20, that was given, and this side was 10 root 3. Remember the pattern was the hypotenuse was twice as long as the short leg, and the long leg is the square root of 3 times the short leg. So there's your pattern if you start to see it. Okay, number 6. Again, the 1 goes across from the 30. There's your 30, so put it over 1. Your hypotenuse, which is across from your 90, is over 2. And then your root 3 goes across from your 60 on the leftover side. So we want A. I want A over root 3 is equal to, we need one of the fractions that has all of the numbers, 3 over 1. So when I cross multiply this, right there, I have 3 on the outside, root 3 on the inside. So I can't multiply the 3 and the 3 together. So it's 3 on the outside and then root 3 on the inside. 3 times root 3. And then b over 2 is equal to 3 over 1. When you cross multiply those, you get 2 times 3, which is 6. 7. So we're going to complicate things a little bit, but that's okay. The way we're doing this, it doesn't matter. Even if they're complicated, you can do them. Always, you see that 60 degrees, then go get your numbers off your formula chart and set them up. So C's on the short side, because here's your 30. So it'd be over 1. Your D would be over 2, because that's your hypotenuse. And then your root 3 goes here on your long leg. Now, set it up. Like I said, don't worry about where things are supposed to be and where they are. C over 1 is equal to 12 over root 3. So we multiply 1 times 12. That gives me 12. So that is 12 over root 3, or if we simplify that, 12 divided by 3 is 4, but we divided by root 3, so we throw a root 3 there on the end. That's a trick. There's a reason why it happens, remember. We're just using our trick to save us a little bit of time. Then D is over 2 is equal to 12 over root 3. So we cross multiply right here. So we get 12 times 2, which is 24 over root 3. And then we can leave it like that, or we can simplify it. 24 divided by the square root of 3. So 24 divided by 3 is 8. And then we divided by the square root of 3, and so we throw a root 3 on the end. And so then what we have is that our final answers, C is actually 4 root 3, D is actually 8 root 3, and then this other side, that third side, is actually 12. Okay, so those ugly ones, we don't have to worry, what I call built-ins, when the root 3 is not where it's supposed to be. Setting them up with proportions makes this really easy. Okay, so again, find your 30 degrees. Put your 1 underneath that number. Put your 2 underneath the hypotenuse. And put your root 3 underneath the long leg. Then set up, don't worry about what it looks like, just set it up. A over 1 is equal to 2 root 3 over 2. Cross multiply, so you do 1 times 2 root 3. Well, that's 2 root 3. And then you divide that by that 2, right? So then we divide that by that 2. Well, this 2 out here cancels that 2 underneath there, and you're left with the square root of 3. And then B, we have B over the square root of 3 is equal to 2 root 3 over 2. Now, you could have simplified it here. In fact, notice this right here. This is one thing that's nice. You could have canceled that 2 and that 2, or that 2 and that 2, and you would be left with B over root 3 is equal to root 3. So that's much prettier to look at. And then remember that you're going to cross multiply. Root 3 times root 3 is the square root of 9. The square root of 9 is 3, or you can go straight to 3. Remember, root 3 times root 3 is 3, if you remember that trick. Okay, so the important part is keeping up with these numbers right here and being sure that you put them on the right side. And then once you get good, you'll get some practice with recognizing when you need to deal and do a full cross multiplying. So we're still cross multiplying, we're just not having to do all the work because there's a lot of ones involved. And so we don't have to multiply those all out. So these numbers are important. You want to keep them handy. Anytime you see a triangle that has a 45, a 30, or a 60, it's going to involve this nice little shortcut.